Hey everyone, welcome to the lecture for 9.1. So this is going to be about null and alternative hypotheses. Now that we're beginning the section where we're going to do hypothesis testing, the first critical step is to state what it is that we're testing. And so these statements are going to be in the form of the null hypothesis, which is written as H naught. So that's an H with a 0 subscript. And it's the statement of no difference between the variables. And the way that I like to think about it is, what is someone telling me that's true? Am I reading a study and they're telling me what the mean is? They're telling me what the proportion is. What are they saying? The alternative hypothesis is a claim that is contradictory to H naught. And this is kind of what we're saying is true. So let's go ahead and look at this first example. Suppose a manufacturer of the XJ35 battery claims the mean life of the battery is 500 days with a standard deviation of 25 days. You are the buyer of this battery and you think this claim is inflated. You would like to test your belief because without a good reason, you can't get out of your contract. So what should we do? So in general, the idea of hypothesis testing is we're evaluating a claim that someone else is making, in this case, the manufacturer of the XJ35 battery, and we want to be able to support the alternative hypothesis with a sample. And so that's really all going to lean on the central limit theorem and everything we've done so far in chapters 7 and 8. But let's just kind of parse it out, stating the null and alternative hypothesis. So what are they saying is true? So they are making a claim on the mean life of the battery. They're also making a claim on the standard deviation, but as we recall from chapter 8, we really only care about estimating means and proportions, right? Like we went from mu where it's mean, and then we had P where it was proportions, and that was 8.1, 8.2, and 8.3. So this standard deviation of 25 days is a little bit of a red herring for right now. We do need that information when we determine how to more precisely conduct these tests. But in stating the null and alternative hypotheses, we just need to know what they're claiming about the mean. So they're saying that the average battery life is 500 days. What are we saying? We think that the claim is inflated. So we're saying that the battery life is less than 500, right? So if you're saying that their claim is inflated, you're saying that they're giving you a number that's too high, which means that you think the true number is actually lower or less than. So the way that we're going to set up our null and alternative hypotheses is we're going to kind of translate these into mathematical expressions. So we're going to write H naught for our null hypothesis. And what they were saying was that the true average mu, or the true mean, was 500 days. And what we're saying is, no, I don't believe you. Actually, the true average is less than 500 days. So you're not making a claim. You're not saying like, well, actually, the average is 400 days. No. You're just pointing at them and saying, liar, liar, pants on fire. Like, so they're telling you it's 500 and you're just like, no, you're a liar. And you're not even giving them an extra number. So hypothesis testing is all about determining whether the alternative hypothesis is true. So we're never going to test whether the null hypothesis is true. We're always going to go for showing that the alternative is true. And so like I said earlier, we're going to use samples to determine whether or not we can be justified in calling someone a liar. I guess that's kind of a snarky way to put it, but that's essentially what we're doing. So we'll either have enough evidence to support our alternative hypothesis, or we won't. If we don't have enough evidence to support the alternative hypothesis, it doesn't mean that we proved the null hypothesis. It just means that we don't have enough evidence to support the alternative. And it's really that simple. So if you're interested in those types of arguments, I definitely recommend looking at truth tables in logic and all that kind of stuff. So here's a hint for setting up your null and alternative hypotheses. H naught always has a symbol with an equal sign in it. HA, the alternative hypothesis, never has a symbol with an equal sign in it. And the choice of the symbol is going to depend on the wording of the hypothesis test. I think in a lot of cases, we kind of just default use equal in the null hypothesis, even if we have an inequality in the alternative hypothesis. And that's fine. So let's look at this next example here. If we want to test the claim that the mean grade point average of night students is significantly different than 3.4, what are the null and alternative hypotheses? So again, what are they saying, right? What is this claim? So the claim is that the mean GPA of night students is 3.4, right? They're claiming that, and we're saying, no, it's not. It's different. It's definitely not that. I don't know what it is, but it's not that. So they're claiming that night student GPAs is 3.4, right? So this is the mean. And we're saying, no, it's not. So in terms of null and alternative, H naught is just that mu equals 3.4. And if I'm saying like, no, it's not true, it's really as simple as just writing down mu equals, just kidding, not equals 3.4. They're telling us it's 3.4 and we're saying no. All right, let's do another example of null and alternative hypotheses. The DPS or DMV, depending on where you're from, claims that on a state driver's test, 40% pass the test on the first try. We want to test to see if more than 40% pass on the first try. So this is a little bit different because now we're talking about proportion. So in the previous examples, it have all been about mean, mu. So now we're talking about proportion. So remember that when we see blank out of blank, right? Successes over trials, that's going to be proportions. If we see a percentage, that's going to be proportions. So what they're saying is that the proportion of people who pass is 40%, right? We know that we can always convert a percent into a decimal. And we're saying it's higher. So the null hypothesis is simply that, remember we use P for proportions, is that P is equal to 0.40. The alternative hypothesis, what we're claiming is true, or at least what we want to show, is that P is greater than 0.40. So remember here that we typically use the decimal form when we're making these assertions. All right, and here's a question that's going to seem really familiar. It is from homework 7.1. So remember I said that this hypothesis testing really leans heavily on the central limit theorem. Well, 7.1 was central limit theorem. So I'm kind of throwing back to that homework assignment. The manager of a computer retail store is concerned that his suppliers have been giving them laptop computers with lower than average quality. The suppliers say, so this is like your tip off, the suppliers say that the mean time to replace is 4.5 years. They say it's 4.5 years. Right, so if as a null hypothesis, they're saying that mu is equal to 4.5 years. What we're saying is we think it's a lot shorter. So we kind of say it 2 times. In the beginning, it says the manager is concerned that the laptop computers are of lower than average quality. Quality is an ambiguous term. Really what we're saying here is the manager thinks that the mean time to replace is shorter. So as an alternative hypothesis, what we're saying is mu is less than 4.5 years. And then another relic from 7.1, the amounts of nicotine in a certain brand of cigarette are normally distributed with a mean of 0.914 grams and a standard deviation of 0.294 grams. The company that produces these cigarettes claims that it now has reduced the amount of nicotine. And you think that this is not the case. So this is a little bit of a red herring because the company is claiming that it's reduced the amount of nicotine, but without the cigarette company saying what the reduced amount is, we can't, in our current skill set, we can't really say what the null and the alternative is. So let's see if we can kind of just look at this in this way, just editing the question a little bit. What if we thought it was higher? Right, so kind of taking this question from 7.1 and just reframing it in a context that's going to be for 9.1. So now it'll have the amounts of nicotine in a certain brand of cigarette are normally distributed with a mean of 0.914 grams and a standard deviation of 0.294 grams. So this would be the claim. The cigarette company is making. We think it's higher. So they're saying that mean nicotine per cigarette is 0.914 grams, and we think it's higher. So the null is mu equals 0.914, and the alternative is that mu is greater than 0.914. All right, so the null and the alternative hypotheses are going to help us determine what type of testing we should use. So there's something called right-tailed test, left-tailed test, and two-tailed tests. And which one should we use? All right, so remember that we're trying to determine whether we have sufficient evidence to support the, alternative hypothesis. And we rely on sampling distributions to determine the likelihood of the alternative hypothesis. major typo. So remember that likelihood is synonymous with probability, and probability is really area under the curve. So if we want to reject the claim for a mean or a proportion, or another way to say that is, if we want to show that the alternative hypothesis for mu or p is true, then we have to use left, right, or two-tailed test, but which one we use depends on how we have structured the alternative hypothesis. So in the first example we had about the GPA, remember that our null hypothesis was that mu was equal to 3.4. So if I'm looking at, I'm not saying, so maybe this is normal, maybe it's a t distribution. Remember how we had that distinction in 8.1 and 8.2 and 8.3, we were using either a normal or a t distribution. I'm not saying which one this is right now, and we will get to that, but it's one of the two. All right, so if they're claiming that mu is 3.4, and we're saying that mu isn't 3.4, then we need a sample that would be super unlikely to show. So really unlikely means like an outlier. Now, unlikely is going to depend on our confidence level or our level of significance, and those are also upcoming ideas. But if we're not equal, we want to use a two-tailed test, and we'll see later that these are called rejection regions. We just want to show that it's not equal. So I don't care if it's significantly larger or significantly lower. I just want it to be far enough away from 3.4 to be like, no, you were wrong. It's not 3.4. Look, these are unlikely events and it's happening in my sample. In the case of the DPS DMV claiming that the pass rate on the test was 40%, and we wanted to test whether or not it was more than what we had for our null hypothesis, was that they were claiming p was equal to 0.4, and we were saying that p, or at least we were wanting to show or get evidence for p being greater than 0.4. So if they're claiming that the true proportion, I guess it's not, sorry, if they're claiming that the true proportion is 0.4, and we just want to show that it's bigger, then we really only care, like we want a sample that is over here, right? If we got a sample that was over here, we'd be like, well, we didn't really show it was bigger, did we? So we want to be looking at where it's bigger. So this is a right-tailed test. This is a two-tailed test. And then in this last example, we're going to end up with a left-tailed test. So this is the one with the manager of the computer retail store. The supplier was saying that mu was equal to 4.5, and the manager was like, no, mu is definitely less than 4.5. So you had your mu here, and you wanted to show that in your sample that you ended up over here something a lot shorter than 4.5. And so this is going to be a left-tailed test. So we're going to give very formal definitions for the rejection region, for the significance level in later sections. Right now, our focus is just, can we state the null and alternative hypotheses? From the null and alternative hypotheses, can we determine whether we have a right-tailed, left-tailed, or two-tailed test?